will be acting on the plank in that direction. Now, I just need to, what I need to do, I need to find what can be the maximum acceleration of this block of small mass m. This is capital M. So here, let us say that the maximum possible acceleration is capital A for this. This is the maximum possible acceleration in horizontal direction. And what can I write? I can write friction is equal to m into A. What is the value of friction? Value of friction is nothing but mu into normal force over here, which is nothing but a small mg, is equal to ma. And if you solve this, m is cancelled. The maximum possible acceleration is coming for the top block. Okay, is coming to be mu g, which is 1 by 3 into 10 by 3 if g is 10, right, meter per second square. So this block can only move with a maximum acceleration of 10 by 3 meter per second square. It can't move faster than that. So if the bottom block is also moving with that acceleration, then it both will be moving together. If this is moving faster than that, then basically this block will be left behind, and relative motion will take place. So they are saying what is the maximum value of capital F for which the block and the plank both moves together. So we'll say, let us say this acceleration is maximum, that is 10 by 3 meter per second square. We just need to write F is equal to ma equation for this plank. So what is F? For net force is F minus friction is equal to mass, which is capital M, into acceleration, which is basically 10 by 3. And once we solve this, we'll get our answer. All the values are given like capital M and small m. And friction we have already found, it's mu mg. So friction, I'm just finding friction separately. Mu, which is 1 by 3, m, which is basically 2, and g, which is 10. So it is 20 by 3. So I can write that F minus 20 by 3 is equal to capital M, which is 10. So it is 100 by 3. And eventually this 120 by 3 will go that side and it will add up. So we'll get 120 by 3 as an answer. Answer is 40 Newton. So this is the maximum possible force. If you apply more force than this, then what will happen? This acceleration will increase and the small block won't be able to, like you can say, keep it up. Is it clear to everyone? Answer is B. Is it clear to everyone? If there is a doubt, please ask. Anyone? Any doubt? Okay, then I'm moving to next question. 1 second, I think someone is asking around. Okay, it's clear. Next is a cube of mass small m is placed on the top of a wedge of mass 2m. Okay, now as shown in the figure, this is 2m and this is basically cube of small mass m. There is no friction between the cube and the wedge. The minimum coefficient of friction between the wedge and the horizontal surface over here, so that wedge does not move. How much is that? So wedge shouldn't move. Now understand why wedge will move. When basically the top block, 1 second. When the top, when this cube is sliding, eventually it is applying a force in that direction. There is no friction. That on this, it is applying a force that is nothing but mg cos theta. And here there is a force on this direction, which is mg sin theta. So on the block, there are forces, which is this mg cos theta, mg sin theta, a normal, and same normal is same as mg cos theta, and same normal is applied on the other plank, right? Wedge. And now it is due to this force that it will try to move in that direction. So just make component of mg cos theta. If you see properly, this is the angle, this is theta. Anyway, here theta is 45. By the way, normal always acts at 90 degree. So this is mg cos theta. And what is theta? Theta is this. And like if you take the component of this also, I'm making component of this. So this further splitting in components. So this component will be mg cos theta cos 45. If this angle, we know that this angle is 45, like this angle is 45, same as theta, and this is also theta. So mg, this component will be mg cos theta times cos 45. And the downward will be mg cos theta times sin 45. So this is the force in this direction, and friction should be able to oppose that. So now let us just write that. And what is downward? Downward is basically this one, which is mg cos theta sin 45. Mg cos theta sin 45. Sin 45, I'm just writing 1 by root 2. This is also 45, so this is 1 by 2, okay? So this force is basically mg by 2, and this force is basically mg, again mg by 2. This is also mg by 2. I'm just removing all the things, just making a wedge. So if you see, this is the wedge. It is having two forces on it. This force is mg by 2 and this force is mg by 2. There is its own force, that is again 2 mg. So this is 2 mg. This is mg by 2. This is again, this is also mg by 2. Here the friction will act, but before friction there will be a normal force in this direction and a friction to oppose that mg by 2 in horizontal direction. So I am saying that normal should be mg by 2 plus 2 mg, that is 5 by 2 mg, and the friction, that should be mg by 2, so that it can oppose that. And here we can get that friction is nothing but mu into n, and they are asking mu only. So mu into normal is 5 by 2 mg is equal to mg by 2. Mg and mg gets cancelled, 2 and 2 gets cancelled, so mu is nothing but 1 by 5, which is nothing but 0.2. So the coefficient of friction should be this. Is it clear? The common mistake is when you consider this friction, we just write mu into 2 mg because this is 2m. But there is an additional force of this mg by 2 which is contributing to the normal and hence increasing the friction. Is there any doubt, anyone? This entire wedge is stationary, so there is nothing to, okay, I am quickly repeating it. This is the wedge, and this wedge is stationary. There is a small block which is sliding on it. If you look at the small block, there are forces. This is mg sin theta, this is mg cos theta, this is normal. So this normal will also be applied on the wedge, right? This is the wedge, normal will be applied. This normal will be same as mg cos theta. So this is mg cos theta. I did component of this normal, which was eventually like this. So I made component of this normal and it came to be mg by 2 downward and mg by 2 in horizontal direction. This mg by 2 friction will be opposing, and this mg by 2 will be combining with this 2 mg to give you the normal. And friction is nothing but mu into n. So mu into n, that is normal, must be equal to mg. We put the normal is equal to 5 by 2 mg by balancing the vertical forces. Is it clear now? Still confused? Is that clear? Okay, then I am moving to next question. Next question is 4 roads, each of length L. 4 roads, they are not, okay, 4 roads, each of length L have been hinged to form a rhombus. Vertex A is fixed to a rigid support. Vertex C is being moved along the x-axis with a constant velocity v. As shown in the figure, the rate at which vertex B is approaching the x at the moment is, it's simple question. Basically, what is happening, just understand, right? 1 second. This is a rhombus. Now, if you see this point is having the velocity in this direction. What about this point? By symmetry, we know that this point will be moving downward and this point will be coming like moving upwards. So let us say that this point is moving with a speed of u in downward direction. This is moving in the speed of v. It is given that in horizontal direction. Just think about this rod. So this is a rod which is something like this. By the way, if you check, this point of the rod is moving downward with a speed of u, and this point is moving in this direction with a speed of v. And since it is a rhombus, and see, as of now, 1 second. So as of now, the rhombus is in the form of a square. So total angle is 90, each one is 45. So this is 45 degree and this is also 45 degree. So I will just say that u cos 45, that is the speed of this point in this direction, must be same as speed of this point in this direction, that is v cos 45. So that the length of the rod does not change. Again, I am repeating the concept, 1 second. Concept is simple. This is the rod and speed of velocity of this point and velocity of this point, their component along the road must be same. So if this is moving, let us say with ux and with that uy, and this point is moving with vx and Vy like that, then I am saying that this component Ux must be same as Vx, so that the length of the rod does not change. There is no relationship between Uy and Vy, by the way. So Ux is what? Ux is like U cos 45. This is Ux and this is like Vx, which is V cos 45. And eventually they are equal to cos 45 cancels, and we get U is equal to V. So the rate at which this point B is moving in downward direction is nothing but V, okay? But 1 second, what are they asking? The rate at which vertex B is approaching the x-axis at the moment. Answer should be V only. 1 second. The x-axis, it is approaching the x-axis. What else can we write? Just a second, I am thinking something. If we go for the same concept, this point is stationary. So the U component along that must be stationary. 1 second. Again, I'm thinking, 1 second, I'm thinking again. So this velocity must be V. This V cos 45. This point is, let's say, moving. Okay, if this point is moving, then this point is like, this is about this point it is rotating, so it can only do motion like this, right? So let us say its actual velocity, it can't go like down, right? Its actual velocity is, let's say, like that, and that should be same as V cos 45. So if this velocity is that, then we will find the component of this by along this. Okay, so this point is moving in this direction because this point is actually doing a circular motion, and this is the center. And what is this? This is V cos 45 V by root 2. So this must also be V by root 2. And if this angle is 45, then find the component of V by root 2 along in the downward direction. So that is the rate at which B is approaching. So B is actually moving with V by root 2 velocity in that direction. That implies in this direction and in this direction, this component will be V by root 2 cos 45. Assuming that this is 45 and which is 45, because as of now it is a square. So V by root 2 into cos 45, that is further one. So that gives us V by 2. So it is approaching x-axis with a speed of V by 2. Is it clear? It can't have an overall downward velocity. As of now, it is moving like, it is doing a circular, it can only do a circular motion because that rod length can't change. So as of now, this is moving in this direction, which is 90 degree to this, which is in the same direction as rod. So it should have a velocity of V by root 2. Is it clear to everyone? Is there any confusion? I'm moving to next question then. Next question says that consider the following diagram in which an inextensible string connects two blocks passing via ring. So this is a ring, like this is the rod. The first block moves with a constant velocity of 2 meters per second, and the second one moves with a velocity of V meter per second. If the ring slides horizontally on the rod, then the value of V is. Okay, so ring, this is the rod and this is the ring, and this string is like passing like this. What can I say? I can say that the downward force, horizontal, and if this ring is sliding with a velocity of V meter, I think this should be 1 meter per second. It's shown in the figure, and V is this block. 1 second. If the ring is slides horizontally, then the value of V is. Okay. So what I'm saying is, just think about the string, and I am applying constraint equation of constraint on the string. Okay. So as of now, just think about, like, separate these two parts of the string also. Now this point with ring, it is moving with 1 meter per second. This point also with ring, it is moving with 1 meter per second. This point is moving horizontally with a speed of 2 meter per second. And this point is moving with that block with V meter per second. This is the situation as of now. Now I will say that if this length is L1, this length is L2, then L1 plus L2 must be constant. the total length of this string. So L1 plus L2 must be constant, and that implies that rate of change in L1 plus rate of change in L2 must be 0. So by with what rate L1 is changing? So first, from this point, this speed is contributing in decrease in speed. Basically, this V implies that V cos 45 in that direction and V sin 45 in the perpendicular direction. This V sin 45 is not changing L1. This V cos 45 is like decreasing it. So I'm writing minus V cos 45, which is V by root 2. What about this one? If this is 45, this is also 45, right? And one like this is increasing. There's like this one cos 45 in that direction and this one sin 45 in this direction. So this one cos 45 is kind of increasing the length L1. So I'll write plus 1 sin 1 cos 45, that is 1 by root 2. What about L2? L2 also write the similar. This angle is basically, this is 30, so this also must be 30. So this is 30 and this is given as 30, so this is also 30. So this 1 cos 30 is decreasing it. So 1 cos 30 is basically root 3 by 2, so that is root 3 by 2. This is the rate at which it is decreasing L2, and here it is increasing. At what rate? Plus, it is increasing at a rate of 2 cos 30. So 2 cos 30 is 2 root 3 by 2. And that should be equal to 0. Now just solve it for V. So this is minus V plus 1 by root 2. And this entire thing is basically 1 root 3 by 2, right? Plus 1 root 3 by 2. Or we can also write this root 6 by root 2. Root 6 by root 2 and is equal to 0. So this root 2 as LCM goes other way around, cancels. V comes here. So V is nothing but root 6 plus 1. So V is coming to be root of 6 plus 1. Is there an option like that? 1 second. Have we done a mistake? Let me do it again. The last calculation part. 1 second. So this is minus V plus 1 by root 2. Is equal to 1 root 3 by 2 is equal to root 3 by 2 and negative of that. So when this root 2 comes here, we get root 3 by root 2. We get root 3 by 2 and negative of that, and this goes, this side becomes positive. So 1 plus this. This is the answer. Is that an option? Option number B. Is it clear? Put a right tick if you have understood, or write clear in chat.
So can you explain this once more?
See, Ayan, basically when this point is moving, actually this point is moving in like 2 dimensions, right? One, this is the string. One component is along the string like this, and other component is perpendicular to the string. So the rate at which length is decreasing is this component. So this component, since it is trying to decrease the length, I wrote this component as minus. And similarly, the other velocity, the 1 meter per second, it was also like this and like this. So this component is trying to increase the length, while this component is trying to decrease the length. So overall, this minus this is the answer. Increase is positive and decrease is negative. So negative of this, positive of this, and same thing I did for the other way around also, so for L2 also. And the rate at which total length is decreasing must be 0, because constant has a differentiation of 0. If you differentiate this thing, what do you get? This thing is 0, the differentiation of a constant, and this is dL1 by dt, rate of change in L1, which is basically this. And the second term is dL2 by dt, rate of change in L2, which is basically this thing, and is equal to 0, which is the differentiation of a constant. Is it clear? If the component is trying to decrease the length, you write it as negative. If it is trying to increase the length, you write it as positive. So here this component was decreased negative and this component was positive. Make sense? Moving to next question. And like answer was B. 1 second. They are getting C. We got also this now. This is answer number B only. 1 plus root 3 by 2. Next question. A block is hanged from a spring in a cage elongation in the spring is x1, which is 4 root 2 mm, and x2, which is 3 root 2 mm, when cage moves up and down respectively with the same acceleration. The expansion in mm in the spring when the cage moves horizontally with the same acceleration. So this is the thing, that this is cage. There are three conditions which are given. So this is a cage, and when it is moving in upward direction with an acceleration, then it is moving downward with an acceleration. In last case, they are asking it is moving in horizontally with the same acceleration. So what would be the elongation in this case? When a spring is in this case, what is happening? Ideally, this is, let's say there is some mass, a block is hanging and mass is m. So what will be the net force? If you see from this frame, this will be mg plus ma, right? You just reverse it and give it to the, so this is the force. So I will write that kx, and what is x? Kx1. So that is 4 root 2, and that is mm, so divide by 1000. This is kx is equal to m and g plus a. This is the first equation. Similarly, for here, the downward force will be mg minus ma, because when you do reverse of that, it will be ma like this for this observer. So this will be mg minus a. So I will write kx2, which is 3 root 2 mm, is equal to m and g plus a. First, you add these two equations. When you add these two, or just divide, let's just divide. So when you divide, k gets cancelled, 1000 gets cancelled, root 2 also gets cancelled. We get 3 by 4. I'm doing this divide by the other, is equal to g plus a upon g minus a. And when you cross multiply and solve, you get 3g minus 3a is equal to 4g plus 4a. And eventually this a comes here, so we get 7a is equal to, one second, we did a mistake. This should be minus a, 1 second. This should be minus a, and that is plus, right? So it should be g of minus a upon g minus a upon g plus a. So 3g plus 3a is equal to 4g minus 4a. Eventually 7a is equal to g, and we get acceleration is equal to g by 7. Is that clear to everyone? This acceleration is coming to be g by 7. Now, again, when it is moving in this direction, block will be something like this. So it is experiencing two forces now. What are two forces? One is mg and another is ma in that direction. So overall force will be in this direction. Let us say this is F. So now I have to write Kx is equal to nu F. What is nu F? So nu F is nothing but root over ma square, ma whole square plus mg whole square. So I am just finding the new force. And that should be the Kx. Is K given? Spring constant is not given. 1 second. I need to put the value of A in one of the equation to get the value of K as well. So K 3 root 2 by 1000 is equal to m. G minus g by 7 is 6g by 7. So this equation also will be useful to eliminate K from here. So put the value of K. What is the value of K? 1 second. I am removing this entire thing. It's taking a lot of space. So I am rewriting this equation. Kx, what is K? K is basically 6 mg by 7 times 1000 by 3 root 2 times x is equal to, by the way, x is in meter, okay? So is equal to root of that. So what is root of that? Root of m square a square plus m square g square. You can take m common and like m square common, eventually m will come out. It is under root a square, which is g by 7 whole square. So g square by 49 plus simply g square. So g also comes out. We get 1 by 49 plus 1, right? That is root of 50 by 49. So we get root of 50 by 7. Now simplify it. So mg cancels mg, 7 cancels 7, and now just get x. X is nothing but root 50 into 3 root 2 divide by 6 into 1000. I am keeping 1000 as it is so that I can directly get my answer in right? So I'll write that this is basically 5 root 2. 5 root 2 into 3 root 2 is 15 into 2. Divide by 6 into 1000. So 3 2s are 3 5s are and 2 2s are. So it is basically 5 mm. Is that clear? Answer is 5. They are asking in mm, it is integer type. Is that clear? Final answer is 5 mm. If there is any confusion, please ask. Okay, I'm moving to next question then. A small spherical ball obeying Stokes' law for viscous force is thrown up vertically with a speed of 20 meter per second is received back by the thrower at the point of projection with a speed of 10 meter per second. Neglecting the buoyancy force on the ball, assuming the speed of the ball during its flight to be never equal to its terminal speed, and taking the acceleration due to gravity g is equal to 10 meter per second square, find the time of flight of the ball in seconds. So see, when basically ball is here, it is going up to a maximum point, then it is falling back to the same point. So what is the speed? Some of the things are given that initially it was thrown with 20 meter per second upward speed. At the topmost point, speed has to be 0 meter per second, and when it is coming back, the speed is basically the 10 meter per second. So there they are saying that it is obeying Stokes' law for viscous force. What does that mean? That means for an object which is moving with v velocity, there is a viscous force in opposite direction, and it is given by, if some object is moving like that, then there is a viscous force, and this viscous force is given by this formula 6 pi eta rv. I am saying 6 is not changing, pi is not changing, eta is coefficient of viscosity which is constant, radius of the spherical ball is also a constant. So can I say it is nothing but kV? So now I will say that when it was going up, what was the forces acting on it? Since when it was going up, the forces acting on it was kV, right, when speed was v, and plus mg. But when it was coming down, the forces were mg downward, but kV was acting in upward direction, because when it was coming down. So now you need to integrate for two different parts. How will you do that? 1 second, I am removing this. So when it is going up, for that motion, I am writing F is equal to ma. What is the net force? Net force is basically mg plus kV. This is equal to mass into acceleration. Acceleration is in downward direction. By the way, acceleration is basically dv by dt, right? But here that has to be negative. Why? Because change in velocity is like minus. Or you can write, let us say in we are writing everything is in upward direction is positive. So it's like net force is this is equal to mass into acceleration. Acceleration is also like negative only, because it will be. So we don't know that acceleration is negative. We just write that, and then we will write acceleration is dv by dt. So one minus has to come in the picture. Now this is minus mg minus kv is equal to m and dv by dt. We need to find time, and we just need to integrate. First we will rearrange it. So I am saying it is nothing but divide with m. So this m is gone. We get k by m, and this m is also gone. And now rearrange it properly. Or do we need to divide? 1 second. I don't think we can without division we can do that. So we will get dv, m is like dv upon mg plus kv is equal to negative dt. This is what we are getting. Integrate both these sides. This is basically velocity is changing from 20 to 0, and time is changing from 0 to t. Integrate it. What do we get? So first is this thing as an integration of m will remain as it is. This integration is basically ln of mg plus kv divided by k. This is the integration. Okay, is equal to, and its integration is simply t. And you put the limit 0 to t. This is minus. Okay, so you'll get negative t at the end, 0 to t. And on this, put a limit from 20 to 0. Once you do that, you'll get a relationship. 1 second, let us try to solve that. I'm using a different thing over here. Can we remove something? No. It is m by k, then ln of, when you put 0, you get mg only, right? So mg minus, so I'm dividing, and when you put 20, you get mg minus 20k, mg minus 20k. This is what we get, is equal to minus t. Just remove that minus, I am calling it t1, and eventually this minus will come over here and it will change this order. So this is the first thing. One second, what are they saying? A small spherical, is there any other information? I'm just checking. 20 received back with 10, neglecting the buoyancy force on the ball, assuming the speed of ball during its flight to be never equal to terminal speed and taking its acceleration due to gravity as 10. Find the time of flight of the ball. Okay, nothing else is given. Okay, this is the first equation. For second, same thing will be there. What will be the net force? Now this time downward force, I am taking downward direction as positive because that is the direction of motion. So net force is mg minus kv. So this is this, and this is equal to ma. I'll write the same thing, but it will become mg minus kv. And when you integrate, it will become dt over here, mg minus kv, mg minus kv, and mg minus kv and mdv, and this is simply dt. So when you integrate again, now again I am putting limit from here to here. I am assuming t is 0 over here. So let's say this was t1 and time is 0 to t2. From top to this point I am talking about. So 0 to t2, and what will be the limits on velocity? 0 to 10 this time. And when you integrate, m will be there, ln of mg minus kv we will get, mg minus kv divided by minus k, and this will be simply again integration t 0 to t1 or t2. So we will get a similar expression for t2. So this is minus t2. One second, we will get plus t2 is equal to minus of m by k ln of mg. One second, when you put 0 instead of, one second, limits I haven't changed. This is 0 to 10. 0 to 10. When you put 10 over here, you get mg minus 10v. Upon, when you put 0, you simply get mg. So this is what you get as t2. What is the total time? Total time is simply t1 plus t2. That is the total time which is being asked. So let us do that. Total time is basically t1 plus t2. And when you add them, basically, as you can see, minus m by k is there in both. And it will be ln of this plus this, right? So we get ln of this into that. That's what we will get. So mg upon mg minus 20k times mg minus, not 20k, one second, it was kv. So here also it will be k. K is the coefficient of viscosity, okay? So mg upon mg minus 10k, and this will be mg minus 10k upon mg. So try to cancel out some certain things. This will cancel out mg and mg. We get mg minus 20k and mg minus 10k. How can we further solve it without any information? One second. I think we can use this information, assuming the speed of the ball during its flight to be never equal to its terminal speed. If it is never equal to its terminal speed, I am assuming that 20 meter per second is the terminal speed. This is the maximum possible speed because there is no other data. I'm just assuming that. So what is terminal speed? Terminal speed is basically when mg and this viscous force, they are equal, right? Then we say that it is the terminal speed. One second. If this is moving with v, then here that won't be a terminal speed. This is always decreasing. So let us just assume if that is the terminal speed, one second, mg will be equals to kv. If I assume, okay, see, when it is moving upward, the mg is acting downward as well as the resistive force, right? So it can't get a terminal speed. So I am taking that 10 as the terminal speed because when it is coming down, then only it can get a terminal speed like mg and this force is equal. So I am taking this final speed 10 as the terminal speed. So let us see what do we get. Mg is equal to 10v, 10k. So if this is 10k minus 10k is 0, that will create a problem, even if we assume that to be 20. And m by k is g by 10, that is 1. This is 1 minus 20. Let's check the solution. I think it's a mistake. First thing we did correct and we got this. 1 second. They are using 0 to t g dt plus k by m. It's kv by m, 0 to t dt, that is a dt, and this is also a dt is equal to dv. Okay, I think it's mg plus kv and dt is equal to dv. And then they use gt, this became gt, 1 second. This became what, 0 vdt, integration vdt. This is v minus u, and they are saying integration of vdt is 0. What is integration vdt? Integration vdt is v is basically dx by dt, and integration vdt is that. So that can't be 0. Okay, throughout the motion, that thing will be 0 and v minus u. Okay, I got a better answer. Okay, I'll tell the method what they are using. Basically, they are saying that the force, but there is an issue in this. I'll tell this solution is also having some issue. What is the issue? Basically, when it is moving in upward direction, that time it is basically okay. If we write vector wise, then we can write that equation. There is no harm in that. Yeah, I think this is correct now. 1 second, let me explain. So if we write net force vector wise, then it is basically mg, g is downward, okay, plus k times v vector. K is again that constant, and that I am writing that is equal to ma. What is a? A is nothing but dv by dt. So I am writing that. Since I am writing the entire equation in vector wise, so there is no harm. Now this entire thing I am dividing with m. So I get this k by m v and just dv by dt. Now what I am doing is I am multiplying dt over here. So we get g dt plus k by m v dt is equal to dv. Just integrate all terms. When you integrate, this thing is basically dt, so I am applying 0 to t. Here also I am applying 0 to t. T is the total time of going as well as coming back. And here it is u to v vector, initial velocity to final velocity. So this we will get as v minus u. This g is constant, it will remain like that, and we'll get just t, right? Is it, and plus this k by m will be as it is, and we will get integration v dt. Integration v dt is basically overall displacement, and from here to here overall displacement is eventually 0 only. So that's why this term is 0. So this term is gone, and eventually we just need to solve this. So g is basically 10 into time. We need to find v minus u. What is the final velocity? If you are taking g as positive 10, means you are considering downward direction as positive. So final velocity is positive 10 minus initial velocity is negative 20. So that is 30 by 10. So we get 3 seconds. Is that clear to everyone? And if you are considering upward direction as positive, then g will be minus 10. Final velocity will be minus 10 minus initial velocity will be positive 20. So this will be minus 30. Minus 30 by minus 10, again you will get 3 only. If there is any doubt, please ask. If it is clear, then also tell. Is it clear? I'm moving to next question then. Next question is, in the arrangement shown in the figure, friction exists only between two blocks, capital A and capital B. Okay, so 1 second. They haven't shown blocks A and B. Where is block A? Okay, I think only these blocks. There are two blocks. They are saying coefficient of static friction mu s 0.6 and coefficient of kinetic friction mu k is 0.4. The masses of the blocks are M1 is 20, which is like top block is A and the bottom block is B. So this one is basically 20 kg and this one is 30 kg. And now they are saying find the acceleration in meter per second of M1 if the force capital F 150 Newton is applied as shown in the figure. So this is 150 Newton. How will we solve this? Just make the free body diagram, you will get everything. So I am making the diagram of both the blocks separately, completely separately. So this is a small block, this is capital block. Capital block has pulley also attached to it. So they are part of the block only, okay? And this is also like, this is also part of the block. So now just show the forces, all the forces which are there. So first force which is acting on block B I am talking about is this F 150 Newton. So first it will be F cos 60 and F sin 60 in this direction. Then there will be tension. Tension throughout this string is going to be 150 Newton. So 150 Newton acts over here, 150 Newton acts over here. At the same time 150 Newton acts over here. Is that clear? These are the forces which are acting. Apart from that, there is mg and there is a normal force. This is m2g and then there is a normal force on this block, right? So let us consider all these forces. So mg is basically, this is 30 kg, so this is 300 Newton. This is a normal force. This is 150. This is also 150 Newton. This is 150 cos 60. Cos 60 is half, so this is just 75 Newton. This is 150 sin 60, so root 3 by 2, so it is 75 root 3. And this is again 150 Newton. So now if you check, these two are cancelling out each other. And this is basically 75, this is 150. So overall this block has a horizontal force in this direction. It wants to move in that direction. 1 second, it's not making sense if it is moving in that direction. If we pull that, there is enough friction. Yes, but it is moving in that direction. Okay, and vertical forces we will say 300, the normal, plus 75 root 3 is equal to 300. The vertical forces I balanced, and I am saying this block is moving in that direction. What about this block? This block is having a force of 150 Newton over here. Then friction will be acting obviously between these two. So if this, then 1 second, what is the acceleration of this block? We need to find the individual acceleration without friction, and then we need to apply the friction for that as per the situation. So I am saying that 1 second, without friction, I haven't considered friction between these two at all. So this block is having a mass of 20 kg. This is 30 kg. Writing for this, it will have a, without friction, it will have an acceleration of in this direction 150 by 20. That is 7.5 meter per second square. This block is having an overall horizontal force in that direction, that is just 75 Newton. So it will have an acceleration of 75 by 30. So that is this acceleration. And it's clearly visible the friction on this, the top block will be acting in this direction. The friction must be acting in this direction and this must be acting in that direction. How much it should be? If it is, like if the friction can be 75, that would be the best scenario. This entire block will be like stationary. Okay, so let us check the maximum values of the friction. So what is the maximum value of see, will static friction act or kinetic? As of now, slipping is taking place. I'll be finding both the friction. So static friction and the kinetic friction, I am finding the values of both. So maximum static friction which can act is how much? Mu into mg. The normal over here will be 200 just for this. So mu, which is 0.6 into normal, which is 200, gives me 120 Newton. This is the maximum static friction. What about maximum kinetic friction? Again mu, which is 0.4 into n, which is still 200. So it gives me 80 Newton. Now, let us say that static friction is applying between them. If static friction is applying, there shouldn't be any motion. So if static friction is 120 Newton, if 120 applies on this entire thing, this is going to move towards right again, because it just have an overall force of 75 Newton in that direction. What if this is just 75 and static? If this is 75, then this is stationary, but this will move, right? It is having an overall force. So static can't act. If it is 115 and the bottom block and this block, both are moving. And if it is intermediate value in between, then also both blocks are moving. So there is definitely relative motion. So static friction can't act. If kinetic is acting, it will act fully. So it will try to stop them as much as possible. But what if 80 Newton acts? If 80 Newton acts, then won't this entire bigger block will move in this direction, and this is also moving in this direction, so that makes sense. So 80 Newton is acting over here and 80 Newton is acting over here. Now still relative motion is taking place. The acceleration of both the blocks are different. So now what are they asking? They are asking, find the acceleration of M1, the top one. So acceleration of this one is 150 minus 80 divided by 20. That is simply 70 by 20, and that gives me 3.5 meter per second square. What about the bottom one? Bottom one is having 80 plus 75, that is 155 minus this 150. So just 5 Newton force in this direction divided by mass, which is 30 kg. So its acceleration is in this direction. Now obviously the bottom one is also moving in this direction, top one is also moving in this direction, but this is moving faster, 3.5 meter per second square. This is very slow, just 5 by 30 meter per second square. So this is slow, so friction is helping it out and friction is opposing that. Is the situation making sense? Answer is 3.5 meter per second square. And that is kinetic friction. The relative motion is taking place between both of these blocks. But shouldn't it be integer? 1 second. Mass is 20 and 30 only. So yeah, let's check the answer. Answer is 1.5. 1 second. They are saying it can move together. Okay, 1 second. I haven't checked that condition. This condition also, there is one more condition which we missed. 1 second. What was this condition? This condition was basically, what if the entire system is moving together? So if entire system is moving together, then look at the top block. It is having 150 Newton over here, right? The bottom block. If you look at the bottom block, overall force on this bottom is basically in this direction, it was 150 over here, and overall here it was 75. I'm just talking about horizontal forces. So overall it is having a force in this direction. If they are moving together, then friction will make sure that both of them are moving together. So friction will act in this direction and in this direction for them to move together. So how, if they are moving with the same acceleration, let us assume if they are both can move with the same acceleration within the limit. So let us say this is F, this is also F. What will I write? I'll write that 150 minus F is equal to M1A, which is 20A. And what will I write for this? The friction plus 75 minus 150, that is friction minus 75 is equal to 30A. So that is coming to be, if you calculate, F cancels and this is just 75 is equal to 50A, and acceleration is 75 by 50, cancel with 25. So that is 3 by 2, 1.5 meter per second square. Just check what is the friction. If you put it in any one of the equation, and friction is coming what? 150 minus F is equal to, or let's just check the second one. We don't have to change the sign. F minus 75 is equal to 30A. 30 into 1.5. That is 45. So friction is coming to be 45 plus 75, which is 120. And 120 is the maximum static friction which is possible. So yes, both of them can move together with same acceleration without any sliding between them. This scenario also we forgot to check. We always have to assume one more scenario where both of them can move together with the same possible acceleration. If that friction is within the limit, then that would be the preferable motion. Is it clear? Is it clear to everyone? If friction is 120, then both will be moving. This will be moving in this direction. This will also be moving in this direction. Both will have same acceleration. And 120 Newton friction is within the limits. Moving to next question. Next question is coefficient of kinetic friction between 3 kg and 2 kg block is 0.25. The horizontal table surface is smooth. Find the acceleration of block of mass 10 kg. We need to find the acceleration of block which is 10 kg. So like all the forces are T1 and tensions and everything is shown. So now just think the kinetic friction between 2 and 3 is 0.25. So what is the friction which can act in this? First think about 2. There is tension T1 which is pulling it in that direction. The 3, it is tension T1 and tension T2 in that direction. Now, and this block 10 kg, just think that entire system is stationary. Now this 10 kg will try to move in downward direction. This is the 10 kg and it is having mg which is 100 Newton and it is having T2. So it will try to move in downward direction. If it moves with an acceleration of A, the same acceleration it also has to move because they are connected with a string, right? And if this is moving with A, then they are also connected with a string, so it has to move with the same acceleration in that direction. As you can see, both of them are moving in opposite direction. So friction will be acting on this, it will be acting in this direction, and on this, it will be acting in that direction. And if it is kinetic friction, it will act fully, right? There is no intermediate value of a kinetic friction. What is the value of kinetic friction in this case? Kinetic friction is basically mu into n. Mu is 0.25, 1/4. 1 second, let me write 1 by 4. 0.25 is 1/4 into normal. Normal over here is basically 20. So it is 10 by 2, which is 5 Newton. This is the friction. Just apply the value of friction, that is 5 Newton, and this is also 5 Newton. Start writing the equation for each and every block. If you write the equation for the first block, what do you get? The 2 kg one. F is equal to ma. So I am writing T1 minus 5 is equal to 2a. What if you write the equation for the second one? It is moving in this direction, so we will write T2 minus T1 minus 5 is equal to 3a. For 10 kg I am writing 100 minus T2 is equal to 10a. And once you add all three, T1 gets cancelled, T2 gets cancelled, and we get 100 minus 5 minus 5, that is 100 minus 10. So 90 is equal to 13, 14, 15, 15a. We get the acceleration. So a is nothing but 90 divided by 15. How much is that? How much is that? 6. So answer is 6 meter per second square. That's all. Is it clear? I just make free body diagram of all three blocks. Just understand what is happening. This block is trying to move downward. So it is pulling this block because it is connected with a string. And since this block is moving towards left, this block is moving towards right. If they are sliding like that, then friction, this should be like this and that. So I just applied all the forces and wrote F is equal to ma equation for each and every one. And then simply I got the acceleration to be 6 meter per second square. Is there any confusion, anyone? Put a right tick if you are clear. I'm moving to next question then. A chain is placed on a rough table, partially hanging as shown in the figure. The coefficient of static friction between the chain and the table is mu is equal to 0.4. The maximum possible length of the hanging part is x. Okay, and the length of the chain is L. What is the value of L by x? So they are saying it is the maximum possible part which can hang, okay, like without slipping. So here is the thing, this is the table, one second, this is the table, and this part of the chain and this part is hanging. So I am saying, let us say this is x. What will be this? This will be L minus x. What will be the mass? Mass of this part, I am calling M1. Mass of this part is basically total mass divided by total length into required length. That is mass per unit length into required length, that is x. So this is the mass of this part which is hanging. What about this mass? This is basically again same thing, mass per unit length into required length, that is this. So now what is the friction? If you check, the friction acting is like this in this direction, because the chain will be trying to pulling it in this downward direction due to this M1G. So the pulling force is basically M1G, and the stopping force is basically friction, which is nothing but mu into M2G, that is mu into normal. So I'll just equate both of them. I'm writing mu into M2, which is M by L into L minus X into G, is equal to M1G, which is M by L into X into G. Just this cancel out whatever you can. And they are asking what is L by X. Mu is 0.4. So 0.4, 4 by 10 into L minus X is equal to X. So 4L minus 4X is equal to 10X. So 14X is equal to 4L. And L by X is 14 by 4. 14 by 4 is 7 by 2, that is 3.5. Is it clear? The approach. What about this mg? This mg is acting in downward direction. There will be a normal which will be equal to this mg, and there won't be any other forces. Is it clear to everyone? Is there any confusion? I'm just equating the pulling force should be same as that, so that it doesn't slide. Is it clear? I'm moving to next question then. The coefficient of friction between the two blocks shown in the figure is mu is equal to 0.4, and the between the lower block and the ground is 0. So there is no friction between the ground and the block, bottom block. The blocks are given velocities 2 meter per second and 8 meter per second respectively in the direction shown in the figure. In how much time, in seconds, the slipping between the two blocks will stop? See, they are given a certain velocity. Slipping will stop when both of them starts moving in the same velocity. That's the logic which is over here. And other things are simple. So these are two blocks. Both of them are having some initial velocities in the same direction. So this is basically a 2 meter per second, and this is 8 meter per second. Let us say the final velocity becomes v after time t. For this also final velocity becomes v after time t. But till then, what was happening? This bottom block was moving faster, so friction, kinetic friction will be acting, right? And here also, here the kinetic friction will be trying to help it out to move faster. So what is the friction? Friction is nothing but mu mg, right? So mu is 0.4, and normal for only this top block, that is 10 Newton. So answer is 4 Newton. 4 Newton is the friction, and it is only friction which is providing horizontal acceleration. There is no friction over here. So there is 4 Newton force which is acting, and 4 Newton is providing different acceleration. What is acceleration of this block? Acceleration of this block is in this direction, which is 4 by 1. So 4 meter per second square. What about this? Acceleration of this block is in this direction, which is 4 divided by 2. That is 2 meter per second square. So now I am applying for the first block. What can we write for the block number 1, which is like 1 kg block? V is equal to U, which is 2, plus AT. A is like 4 into T. For second block, what can we write? We can write V is equal to U, which is 8, plus A is minus 2 into T. And now either remove V, one second, they are asking time, so directly remove V, equate V and solve for T. So 8 minus 2T must be equal to 2 plus 4T. That gives us 6t is equal to 6. So t is equal to 1 second. That's the answer. After 1 second, both will be having a speed of 2 plus 4, that is 6 meter per second. So its velocity will increase to 6 meter per second, its velocity will decrease to 6 meter per second, and eventually both will be traveling together with the same velocity. So there won't be any slipping in between them. Is it clear? If there is any doubt, please ask. Are these clear? Any confusion, anyone? I'm moving to next question then. Answer is after 1 second, slipping will stop. A particle of mass 2 kg moves with an initial velocity v is equal to that. 1 second. Okay, I am explaining that once more again. See, the top block was having this u. We say the after t time velocity becomes v. For bottom block also this is having u, and let's say it becomes v after t time. And the friction is acting in between. Since this is moving slower, this is moving faster. So friction 4 Newton will try to stop it and will try to accelerate it. So it increases from 2 to 6 and it decreases from 8 to 6. And once both are moving in 6 meter per second, why would friction act? So friction stops acting and there is no more slipping between them, right? And that happens after 1 second. So I just wrote the equation v is equal to u plus at for both, and eventually solve that for time. And I got 1 second, and the velocity, common velocity will be 6 meter per second. Is it clear? I'm moving to next question now. Question is saying that a particle of mass 2 kg moves with an initial velocity of v is equal to that 4i plus 4j meter per second. A constant force F is equal to 20 J Newton is applied on the particle. Initially, the particle was at 0, 0. The x coordinate of the particle when the y coordinate again becomes 0 is given by. So just understand this is the question of motion in 2D. So just split your motion in two parts, one along x-axis and along y-axis. If I talk about along x-axis, so along x-axis, what is the velocity? Initial velocity, I am calling it ux rather than vx. Initial velocity along x-axis is nothing but 4 meter per second. Initial velocity along y-axis is nothing but 4 meter per second upwards. So I'm writing plus 4. Okay. What about force? Force is in y direction only. So see, there is no force along x, so there won't be any acceleration along x-axis. Now there is a force along y-axis, that is 20. So acceleration along y-axis will be the force divided by mass. What is mass? 2 kg. So it is 10 meter per second square along positive y. And if it is positive y, this speed is, why would y become 0? 1 second. Is applied. Initially the particle was at 0, the x coordinate of the particle and y coordinate. I think this should be minus 20 j cap, okay? Then only question will be true. So if it is minus 20 j cap, then acceleration will be minus 10 meter per second square. Now think, this y, initial y is 0, initial x is also 0. What is happening? The particle is moving like that, acceleration is like that, minus 10 meter per second square. So particle will come back. How much time will it take? For that, I am just applying s is equal to ut plus half at square. What is displacement? If it is coming back to the same y, same like when its y coordinate again becomes 0. So displacement would be 0. What is initial velocity? Initial velocity is 4. Time I have to find plus half. Acceleration is minus 10 into t square. If you solve that, you get 4t is equal to 5t square. One is at t is equal to 0, other t is 4 by 5, that is 0.8 seconds. So at t is equal to 0 it was here, after 0.8 second it will come back. Okay. Now what is happening with this? This was 0, it was traveling with 4 meter per second and it will remain moving with the same velocity because acceleration is 0. So the distance displacement travel is just speed into time. Time is 4 by 5 or like 0.8. So we get 3.2 meter. So it travels a distance of 3.2 meter. So what will be the x coordinate? X coordinate will be 3.2. That's the answer. Is it clear to everyone? Is it clear to everyone? 1 second, let's check the answer. Yeah, acceleration is minus 10 JK because force given is wrong. Okay, force should be minus 20. Next question says, the block A and B in the figure are connected by a bar of negligible weight. Mass of each block is 170 kg. Mu A is 0.2 and mu B is 0.4, where mu A and mu B are the coefficient of limiting friction between blocks and the plane. Calculate the force developed in the bar. So how much force is being developed in the bar? Okay, so they are connected by a bar and mass of each block is given, coefficient of friction is also given, and limiting friction. Okay, calculate the force developed in the bar. You have to look at them separately. Okay, so if you first just forget about the bar, this is one block, this is the other block. What are the forces which are acting? I am talking about mg sin theta and mg cos theta. For mg sin theta and mg cos theta, those 15 and 8, they are given in the figure. Okay, so here if this is theta, this is 15, this is 8, then you find the hypotenuse first, that is under root 15 square plus 8 square, that is 225 plus 64 root of 289, that is
17.
okay, good. So that is 17. So overall this is 17. Why I am finding 17? Because I want to find cos theta and sin theta. So from here I'll be using sin theta as 8 by 17 and cos theta as 15 by 17. Now, what is the force which is acting in this direction? Mg sin theta. What is mass of A? A is basically, each is 170 kg only. So this is 170 into sin theta. So 170 into sin theta mg. 1 second. This is kg. So 1700. That is mg, and sin theta is basically 8 by 17. 17 gets cancelled. It is 800 Newton. 800 Newton is acting in this direction. Same way 800 Newton must be acting in this direction also. Right? Now, what about the friction? Now, both are wants to move in downward direction. But if it is moving in downward direction, 1 second, there is a rod. Rod can either apply forces like that or can be applying forces like it can pull both or can push both. Okay. So what will happen? We'll find that later. Just put the friction first because coefficient of friction is different. I'm finding this value first, that is mu mg cos theta. So what is that? Is like mg cos theta is normal. I am finding this value. So for first block A, it is 0.2 mg, which is 1700 into cos theta, which is 15 by 17. So 17 cancels out. It is 15 into 0.2. That is 300 Newton. So friction which can act over here is 300. What about this? This is 0.4 into 1700 into 15 by 17. So friction which can act over here is 600, double of that. Now this is more friction. So I will say rod is kind of trying to pull it. Okay. So more friction is kind of stopping it. That is 600 Newton. Okay. And here this rod is trying to pull it like that. And less, see, overall it is still moving in downward direction. Okay, can we say it will be 300 like that? 1 second. 800 and 800 is 1600. Total downward force is 1600. If both the friction try to stop it, then still it is 900, right? So both the friction will be acting along upward the plane. And tension, what about tension? If you see it is moving in downward direction, we'll find the tension, don't worry. Okay, so we just need to calculate the force developed in the bar. We need to get T. For T, just write the equation and let us say both of them are moving with same acceleration A in downward direction. For first, what will be the equation? Equation will be 800 minus 300 minus T is equal to MA. What is M? M is 170 into A. For second, I can write T plus 800 minus 600 is equal to MA. divide these two or just equate these two, so you get like the value of t directly. So once we equate them, what do we get? This is basically 500 minus t is equal to, this is basically 200 plus t. So this t goes here, this 200 goes here, we get 2t is equal to 300. And eventually tension is nothing but 150 Newton. So that is what is the force developed in the rod, the bar. Is it clear to everyone? Is that clear to everyone? Either say yes or just write something in chat or put a right tick. Only one right tick is there.
Clear, ma'am.
Okay. Moving to next. A solid sphere of mass 3 kg is kept on a horizontal surface. The coefficient of static friction between the surface in contact is 2/7. What maximum force can be applied at the highest point in the horizontal direction so that sphere does not slip on the surface? Now this question is, we need to make the diagram. So a solid sphere of mass 3 kg is kept on a horizontal surface. So this is the horizontal surface. The coefficient of static friction between the surface, mu s, is 2/7. And what maximum force can be applied at the highest point of the point in the horizontal direction? So I am applying at this point in horizontal direction, I am applying some force. This is F. And they are saying so that the sphere does not slip on the surface. Now there are two things. One thing is, due to this force, if you check, this is like mg which is acting in downward direction, right? There is a normal which will be same as mg. So friction will be acting in this direction, right? It is trying to rotate at the same time, trying to slide. 1 second. This is 30 Newton. This is mu mg. So mu is 2/7. Maximum I am applying. So mu is 2/7 into 30. 60/7. So F should be 60/7. 1 second. It's not about the center. What can I write? Torque should also be 0. If it is stationary, why would otherwise, like about this point, it will try to rotate like this. If this is the situation, then it will just try to rotate like this, and eventually the friction will act in opposite direction for that purpose. 1 second again. Solid sphere of mass 3 kg is kept on a horizontal surface. The coefficient of static friction between the surface and the contact is this. What maximum force can be applied at the highest point in the horizontal direction so that the sphere does not slip on the surface? And if friction is acting in this direction, then overall it will try to slip. I think answer should be 0. 1 second, let me check. It's F is greater or equal to 20. 1 second, let's check the solution. Are we 1 second? Yeah. So they are saying that F plus F is equal to mass into acceleration. Friction will act in same direction, okay, so that no slipping takes place. And okay, so F should be greater than 20, but there will be an acceleration, no? Okay, it's pure rolling. It's not from the Newton's laws of motion. It's from pure like rotation. So there shouldn't be any slipping, means it can rotate, like it can do pure rolling. It can basically rotate without slipping. That's what which is happening over here. So here, if the friction force is in this direction, what will happen? That if you see about this point, the center, the sphere is trying to rotate like this. So this point is like slipping in that direction. So the friction which will act will start acting in that direction. So let us say we are applying, it was 60/7. Remember mu mg? 2/7 into 30. So that is 60/7 Newton. That is friction. And this is F. Now we just need to apply two equations. One equation is F is equal to ma, that is F plus 60 by 7, that is the net force is equal to m, which is 3 into a. The second equation we can apply about this point is basically torque is equal to I alpha. So let us say that about this point, okay, one second, we can talk about this point also. Torque is equal to let's write about the center. Torque is basically F into R minus small f into R, or you can say F minus F into R. Capital F minus small f into R is equal to, what about I? Moment of inertia for a solid sphere is given by 2 by 3 mr square. For hollow it is 2 by 3, for it is 2 by 5 mr square, okay? So 2 by 5 mr square into, this is I, and what about alpha? Alpha, see, if it is pure slipping, then can I write A is equal to R alpha? If it is A acceleration and it is moving with alpha, so this equation will be true. So alpha is nothing but A by R. Now just try to simplify. This R is gone, this R is gone from here, and we get F minus 60 by 7, that is friction, is equal to, what are we getting over here? 2 by 5 into 3 into A. So that is 6 by 5A. What we can do is, we want to get capital F. So, okay, there are two equations to a variable. Let's just remove A. So divide that. What will we get? F plus 60 by 7 upon F minus 60 by 7 is equal to 3 divided by 6 by 5. 5 by 2. So we get 5 by 2. Cross multiply and solve. We'll get our answer. So let me solve that. Okay, if you cross multiply and solve, we get 2F plus 60 by 7 into 2 is equal to 5F minus 5 into 60 by 7. So eventually this thing goes this side and this thing goes other way around. We get total 3F is equal to, this is basically 2 plus 5, 7 times 60 by 7. So 7 is cancelled, 3F is equal to 60, F is equal to 20. That's the answer. Is it clear? See, when capital F is maximum, friction is maximum. So when I am using maximum friction, I am automatically getting maximum possible force. So maximum possible force is 20 Newton. Moving to next question. Is there a doubt? Write in chat if you have any doubt. I am moving to next question. A particle is projected on a frictionless inclined plane of inclination 37 degree at an angle of projection 45 from the inclined plane as shown in the figure. If after first collision from the plane, the particle returns to its point of projection, then what is the value of reciprocal of the coefficient of restitution between the particle and the plane? So here is the thing. Basically, its particle is coming back to its original position again. So this is basically an inclined plane. Particle is going like this at an angle of 45. So it's hitting it like this. And eventually, it is, when it is coming back, it's coming to the same position again. What can I write? If it is moving with the same, like if it is returned back with the same speed, won't it follow back the same path? Basically, if you throw something like this, and it is doing this motion, if you throw back from here with the same speed, it will follow back the same path. So whatever is the speed with which it is hitting the floor is the same speed with which it is again coming back. Okay. So from that, what can I find? It is U. A lot of things are given. One, the angle of the plane is 37 degree, and this is basically 45 degree. And U is given. One second, U is not given. So this is U. So I'll say this, I'm treating this as x-axis, okay? So acceleration in this direction is basically G sine alpha, okay? So G sine 37. And sine 37, 3, 4 and 5. So sine 37 is basically 3 by 5, okay? So G into 3 by 5, if I take G as 10, this is basically 6. So acceleration in this direction is 6 meter per second square. And what about this acceleration? This acceleration is G cos 37. So G cos 37 is basically 4 by 5, 5 twos are, so it is 8 meter per second square. Now let us get the velocity. This velocity was u by root 2 and this velocity was u by root 2. What is final velocity when it is hitting? Let us say this is v. Okay, so I am saying let's say this velocity be vx and this velocity be vy, and just apply the equation and let us say the time taken is capital T. What will I write? I'll write for vertical direction, I am writing for this direction. I'm taking this as positive, this as negative. So I'm writing v square, we can write v square is equal to u square plus 2as. As is 0, so v square must be same as u square. Yeah, we can do that. I'm writing this v square is equal to u square plus 2as along that direction. So final velocity square is vy square. It is equal to initial velocity square is, okay, I don't know u, so that is not useful as also. Okay, so but I know that this is going to be u by root 2, right? Using that v square is equal to u square by 2as. In that direction, displacement from here to here, like it goes like this and comes back. So displacement is 0 and eventually they will be same, so that will be u by root 2 only. What about the other thing? Other thing I can write v is equal to u plus at. So or v square is equal to, that also won't make any sense. One second. The final velocity has to be u by root 2 like that and vx like this. If it is hitting like that, then only it will come back to the same position again. So the coefficient of restitution is just depends on that. The velocity of approach and velocity of separation. Is there a friction? One second. Reciprocal of coefficient of restitution. And one more point that is important. See, this is the surface. When the ball is coming, let us say like this, the coefficient of restitution just depends on the incoming speed towards it and outgoing speed, right? The velocity of approach and velocity of separation. It doesn't affect anything like that. And if you check, the plane is frictionless. So there can't be any force in this direction. Means Vx has to be 0. Otherwise, when this ball hit, so initially it is having this and this velocity. After hitting it, it will be left with that velocity. So if that velocity is left, it can't go back on its initial position. So it has to hit like perpendicular. So Vx must be 0. You got the logic behind that? Vx must be 0. It has to hit in a perpendicular manner. So I'm just applying Vx is equal to 0. So I'm just v square is equal to u square plus 2as. Will that help? Yeah, let us do that. And time period is also there. We need to find this time period anyway. So I'm finding this time period. I'm finding this time to go up and this time to come back. These two times will be same and twice, like addition will be total time period. I'm simply writing v, which is 0 over here, is equal to u by root 2, which is v is equal to u plus at. Acceleration is like minus 8 into t, which is small t, and the time comes to be u by 8 root 2. And when you make it twice, you get the total time of flight. So that is u by 4 root 2. That is the time period of the flight. And now to get this Vx is equal to 0, I am applying this v is equal to u plus at in x direction. So final velocity is 0, that Vx must be 0, is equal to u is like u by root 2 plus acceleration. One second. Acceleration is this 6 minus 6. So minus 6 and time is u by 4 root 2. Can we solve that for u? 3 by 2. It's like u is cancelling out. We don't get anything from there. Where are we going wrong? Time period is depending on u is okay. That is fine. and it is 8 only. So we got time period of, we find the final velocity. I think final velocity we can find if we use the same time period. 1 second. Let us find Vx. Let us not assume Vx is 0. So Vx is u by root 2 minus 8. And what about time? Time is total time period u by 4 root 2, which is 4 2s. So it is basically minus u by root 2. So the final velocity is in this direction. So it's hitting like this, like this. It is having this velocity and this velocity. This is more, and this will become, 1 second, this deceleration is more, so it should, this gets reversed and this gets just in the opposite direction. Okay, 1 second, I did a mistake there. This acceleration, my bad, this acceleration is simply 6, not minus 6, not in x direction. We have to use 6. So that gives you 3 by 2. 1 minus 3 by 2 is minus half. So final velocity still is negative. It can't be. Otherwise, it's this portion and this plane. It has to be like that. Let's check solution. 1 second. I think we are slightly going wrong somewhere. It's 3. Okay, they have used directly formula, not basics. So range is this, and 1 second. It's basically like this is G sine beta, this is G sine alpha, sorry, G cos beta. Give me a second. G cos beta. I'm just trying to, time of flight is capital T. Capital T is basically this. We were getting T is equal to 2u. Sine alpha is sine 37. Sine 37 is 3 by 5. And divide by G cos beta. So, 1 second. Which one is G sine beta? This is beta is 37. So, it will be sine of 45 degree. And into G cos beta. So cos of 37 is 4 by 5. Yeah, we were also getting that only. 5 2s are, this is 8. 2 cancels, u by 8, and this is 1 by root 2. Getting u by 8 root 2. This is the time. 2u sine alpha by g. Okay, we were getting, okay, I think we did some mistake. 1 second, I got my mistake. This acceleration was 6, this was 8, and this was u by root 2, and I was finding v is equal to u plus 8t, so minus 8t, and from here t is nothing but u by 8 root 2. And it should be twice of that. But here we are getting 2 into u into sine alpha, which is sine 45. 1 second, this is alpha and this is beta. Sine 45 is 1 by root 2 divided by g, which is 10, into cos 37. Cos 37 is 4 by 5. So 5 2s are 2 is cancelled. So u by 4 root 2. Yeah, we were also getting the same thing. U by 4 root 2 is the time period. 1 second. Till this point we are fine. Then we are saying we get this thing. What are these equation? Range is basically ut plus half at square. Ut plus half, 1 second, half a t square. I think we will postpone this question. This question solution is not clear. We'll continue next class, okay? I'll explain this one in next class. Let's just end the class because there are a lot, like it has talked in parameter and not explaining what are the parameters are. So we'll continue the same question in next class, okay? I'm ending the class. Bye bye.
Okay, ma'am. Bye bye.